PTC Creo Parametric 3.0, Lesson 22, Part 6. In this lecture, we will cover how to do the coupling assembly. I've got it on my screen here, but one of the things we have to note is that some of the parts you created, which are the three main ones, and other ones are taken from the library of parts or from the CAD resources site. Either way is fine, but you should learn how to do the way you should learn how to at least do the one from the browser and the 3D part space. Basically, we are going to be taking the parts from the metric library if you want to do it this this particular method, and then you're going to select the category that you want to work with, washers, whatever it is. And if you look in the PDF, you'll see that the jam nut and the socket head cap screw, the actual path is given to you here. And if you follow it along, you should be able to pull each one of these parts out. Now, that's one method. The other method is maybe a little bit simpler in the sense that it's all in one spot. But in the CAD resources site, you'll find, go to it. Click on the book cover and click on the assembly exploded view of the coupling. And take this and extract it to your working directory, wherever that is. And you'll see that those components are there for you to work with. Alright, so I already have it in session and the components have been assembled, so we're going to take a look at each one of them individually, and in some cases we'll just redo it and see what we have for our options. One of the first things you want to make sure is when you put it together that you do an analysis at the end of it. So we'll work kind of backwards here and we'll do a preview and we'll see that is there any interferences, there are no interferences. So as you do your assembly, you might want to run that analysis every once in a while to make sure you're getting the components in there correctly. The first component that's going to go in there is in the assembly is of course going to be the shaft, and then the second one is going to be the taper coupling. So let's go and edit the definition of that one and take a look at the constraints that were used for it. So change this into hidden line, and you'll see that you have first one is coincident, which are the two tapered shapes coincident with each other. And then you have the key seat coincident. And then you have a distance one, because we found that we can't get this in there unless we have a distance. Now this is going to be put in there and then eventually screwed down. There's going to be a nut here on this end. So in reality, it doesn't have a precise fit in that sense. So we looked at those, and let's put them on. Let's put it on our own, and we can do that by taking these and suppressing them, like so. So probably be a good idea to have your tree filters so that you can see your display items here and maybe suppressed also. And I have everything turned off, so I don't have any of my datum features shown. So let's go to the model. We're going to assemble, and we're going to assemble the coupling number 1, and that's what I called it here, which is the taper coupling. And I'm going to click on the face here for the taper area, and then with my right mouse button filter to the same thing on the coupling. That's one. Okay, now we also have to index it. If we look, we can see where it's not going to go on there perfectly. Now I'm going to turn off the spin so that when I rotate it, it'll rotate right about that position. Now, one of the things I could do is I could drag this out, but the funny thing is that that coincident doesn't seem to attach itself very well conical shape to conical shape, or taper to taper. So I'm just going to drag this out and take a look, and you'll see that there are the two key seats. So we're going to add a constraint to this surface of the key seat and to the one inside here. And let's see what we get when we do that. We got normal, so let's try parallel. We'll see that they do line up at that particular point. All right, so we have that one in there. We're going to want to add one more constraint here, and that's from the end face here. A variety of places we could go to. Let's pick the very outside so it's easier to see. Now, if we stop there and we did an analysis, we might see that we need a particular distance. So I'm going to come out of there and go into the tools and into the analysis and global interference and see what we can come up with. Well, it's not giving us any interference. So we're kind of lucky at this particular point. If you do get an interference, then you must add a distance to it. In other words, change it from coincident to distance. So I'm a little surprised that that worked out so well. What I want to do is I want to visually test to see if this is working. And I'm going to go in and click on front. And I want to go very, very far into the zoom of it to see whether or not where the two items meet. And you can see right in here that it does have sufficient room and it's not intersecting. So again, you'll do this analysis, and if you do have a lot of red showing up, then what you want to do is change the distance or add a distance to it. All right, so let's move it around a little bit. And the next one we could put in is the I'm going to go around up in here. Let's say we want to go and put the key in up over here. I'm going to just click on this and I'm going to hide it so I don't have to deal with it in front of me. And we're going to go to Model and Assembly, select the key, and the key, I'm going to pick the face here and the face here, and let's make those coincident, and let's flip it, see where it is. Okay. All right, just move it over in here a little bit. So that's coincident. And let's add a new one. How about this face of the key to the face of the key seat? That's also coincident. Let's add one more. We want to know where it's going to slide in here. Let's change the filter to edge and click on the edge here. Let's see if it'll pick the edge. There's the edge using my right mouse button. You can go down and change the filter instead. And that one's coincident. And again, in every case, you should see whether or not these are properly sized. And we'll run an analysis global interference again. And it looks like it's okay. All right, so that's our key and our coupling. Let us, where is my coupling? Let's unhide it. So rotate it around. And let's put on the washer that goes in here. And I'm going to select the curved face inside and just the threaded area here. You'll notice that it's very sloppy. I'm going to also select here and the bearing area, and you're going to need to open up this and get a size on it. Open up the part and measure this first and find out what it should be. Obviously this is very sloppy. We won't do that. So we do want you to go in and measure, see what's going on with these differences here. This one is saying that it's 30. By the way, it is a metric, so you have to pick metric when you create this. And this is 33. So you can see this is very large. So if I activated that, double click on it, there's 33. And make that 30. Regenerate. And activate the assembly. So change the size there. Next one, we want to put on the other coupling. So assemble coupling number 2. And on this one, we could actually pick the face here. This is going to be flipped. And then we can pick one of the one of the dowel holes on each side. So for instance, let me pick this one here and pick one here. It's smart enough to know that this is approximately what it should be. You can see that it's not completely aligned. So we add one more and the dowel hole to the dowel hole, and it is fully see what I have here for a view. Nope, don't want that. So primary larger components are in there, and I think I forgot to put in the nut. I did. So not a big deal. We just go over to our, we got the coupling. Let's go to the first coupling and hide it again. And actually let's hide the second coupling also and see what happens, what it looks like. So at this point we could assemble the nut. How come I'm not seeing it? Oh, right here. Sorry. I'm just seeing it being listed as a jam nut. So we'll pick on the curved threaded area. Same thing on the nut. And then on the bearing face, this will be coincident. And flip it. And that's complete. And bring back the coupling. Unhide. And bring back the other coupling. All right. So as far as the dowel pin goes, assemble the 2 dowels. guess we'll put it in here. And I'll pick here. And the face here. And you can keep the distance and slide it in. Too far. Actually, might even be too long. Let's try to see what happens if this is coincident. Oh, looks okay. All right. Check. And with the dowel, let's pattern that. It should come back and say, oops, it's fill. It doesn't say reference pattern. So when this set of dowel holes was put in, we did not obviously make a pattern. So we can't pattern that item. Now we could go Control C, Control Paste, and it's looking for another hole here. We can pick on this one here, and everything else should be the same. There we go. So we have our dowel pin in. Next thing is putting in our socket head cap screw. Rotate it just a little bit. Zoom up. So assemble. Get your socket head cap screw. Let's open up the window here. So let's pick here and pick here. And then we can drag this to the other side if you want. And obviously we are going to add another one and bring it out a little bit farther. Could flip this obviously, but let's add new constraint, and let's select the bearing surface here and the counterbore surface, and let's flip it like so. And in reality we could add another constraint here. I'm going to go over and turn on my datum planes. Ooh, kind of a mess. And new constraint. And it's going to be pretty tough to select this. What we want to do is we want to get a plane going down the middle of the socket head cap screw. So I guess we could come over here and we could say datum plane and select this one. And we want something to reference on the other part. Let's see, that one goes down the middle. This one goes perpendicular, I guess. Let's see if we can get it to work. And placement. And we will, instead of normal, we'll put angle offset. And that allows us to turn so that our hole can be placed in a certain way. Let's turn it out so. Very slow for some reason. And it's fully constrained. Middle mouse button. Something's wrong. I forgot to index this correctly. I put in the coupling number 2, but I put in dowel pin to dowel pin. I really should have matched some of the other items in here, the Let's turn this off. Interesting, never did it this way before. I have this one on incorrectly, so let's edit definition of that, and let's on placement, let's remove this one, and let's remove this one like so. And so we have coincident. I think what we should do is we should go and turn on our axes and add one. Let's delete all of them. And let's pick axes. And then the axes going down the middle here. Let's start off with that. And then a new constraint. Let's go and pick. We could pick the axes here also. And then the axes in the slot. This here is in the hole. So let's see what happens if I pick this one. And they look lined up. New constraint. You know, we do have one more direction we have to control. So I'm going to pick in here and right mouse it in here. So let's see what happens when I do that. It seems okay. The only difference is I do want to go back over to my screw and check that angle out. Let's try 90 and see what happens. How about 75? It's even worse. So I think visually is still the best way to do it here. Oh, it looks pretty good. Maybe a little bit more. We could try 120. That's what it should be. So next we want to put on our slotted hex nut. So and let's work with it here. Let's pick this bearing surface and the bearing surface in here. And then select the thread surface and the thread surface of the screw. And let's flip the constraint. Oh, should be flipping. The distance here, this should have been coincident. And flip, like so. And we'll try, and we'll add one more, hopefully. Click on here, and click on here. Oriented about coincident. Doesn't like it. Parallel. Well, let's try parallel. All right. Looks good. Anybody who's an engineer would know that you're not supposed to put a cotter pin on moving pieces of equipment like this, but, well, this is just for practice. Assemble. Cotter pin. We'll pick the surface here, and the end here. And we'll, can't pick this. These have a slight curve to them, I found out. So I'll turn on the plane here, and hopefully pick on this one. It says it's invalid. Let's, how about normal? No. Parallel? No. Distance. There we go. Let's see what we've got. So we have a distance here. We want this to be, let's say, I'm going to go 25 and just hit enter and see what happens. Oop, a little too much. Like so. And check. Now, what we're going to do is something a little bit different. We're going to activate the Cotter Pin. And we are going to edit the definition of its trajectory. Your dialog will be different if you've done it like this. Well, maybe not. Maybe you're going to come up with the exact same thing. Done. And go in here like so. Hope you can see it. So we've got the section in here. And what we're going to do is we're actually just going to add a curve on the end here. In other words, we're going to bend it. I think I'll drag this in. And let's go up to arc and pick on the end. Like so. Pick on the end. Like so. Incomplete. Doesn't like me for some reason. Open sections. The start point must be the end point. I'm not sure what it's telling me here. Huh. Never had this trouble. Oh, I'm so sorry. I still have my starting point here. So if I click up on top and I make this the start point, it should work now. And let's just do this one a little bit different shape. Check. Okay. And you can see it. Kind of cool. Let's activate the assembly and turn off the datum features. Very slow. Going faster than it wants to go for some reason. All right, and there's your Cotter Pin in there. It's bent. Now, what you should do is should be able to take those items, Cotter Pin, hold on your control key, slot nut, and socket head cap screw, and make them into a group. And with any luck, you group them and then pattern them. And it should say reference up here in the type because that was put in with the pattern. Check. Oh, everything but the Cotter Pin went in correctly. And this does happen. I've seen this happen before. So one of the things we could do is we could go to the original one and try to back it off. Also, if you notice that the angle changed a little bit. I'll take that back. The angle is okay. It's just up in here. But you're going to have to change the... Let's go back in there and go into edit definition of the Cotter Pin. And see the placement and the distance. See what's going on with it. Offset 20. I just want to go to 0 for the one, see what happens. Okay, I did -5. How about -10? Correction. How about -20? Okay, now it's coming out again. It's a little too far. So let's try to get back a little bit. Seems to be okay. Check. I don't know if all of them are going to go back in correctly. What's going to, I think, happen is we're going to get some of them hitting inside here. So let's move this over and let's zoom in like so. And let's turn on our coordinate system. We're going to need that. Let's see both. Okay, here's my coordinate system down here. And I think, if I'm not mistaken, the x-axis goes down the middle of the socket head cap screw. So there's a set of commands, component operations. The old menu manager will pop up. We want to transform. It says select a coordinate system. I will select this one. And then select the component you want to rotate. I'll select the parent here. And OK, rotate, and we want the x-axis, and well, I'm going to guess about 45 degrees. You'll have to experiment with this to make it work. Done, return, done, and regenerate. And it turned it. It says it didn't like where my key is. Oh. Okay, something's wrong with the key, but regardless, you can see here now we have these facing separate positions. And the third one seems to be okay also still. So we've moved those. Something went wrong with my key. I don't really know what it is. So I could go in and I could investigate. Edit definition. Doesn't like something in here. Let's come off of here again. Let's go in and let's hide. Actually, let's hide these two items. And for some reason my key has gone slightly crazy. In fact, I don't even see my key. It looks like it went and popped the other direction. I have no idea why it did that. That one looks okay. This looks okay. And that looks okay. But I'm not showing the key at all. So let's go in here and see what's going on. Well, I can't see anything. It's not even showing up. I'm not sure what happened. So at this particular point, you'd be better off just putting the key back in. I'm going to resume this one. See what happened. I know that's cheating. I put the other one back in, but basically it's the same thing. Get rid of them and get rid of the one I stuck in that time. Doesn't like my pattern here either. Not sure what happened with that one. All right, let's end by making sure that we have these. You're going to want to create a exploded view and to use in your drawing. So you're going to want to position it in a certain way. That I have a very odd exploded view in this particular one, so it doesn't do any good. I originally created this with wrong units, and I changed the units, but I didn't use interpret. I did something else. So you can see mine is exploded in pretty odd ways. that's the default position. You don't want to use that anyway. So basically what you're going to do is you're going to create your own view, just like you did in lesson 9 in the book. Create the view that you want. Select the view, create it. Establish how you want it to look in space, and then do that. And then go in and create using the view manager, you're going to want to go in and create an exploded view. New one. And let's go in with options and see, move with children. So click on this. See if I can get them all to move. No, everything but. My system is very slow. Very slow. So you're going to want to explode this, make a really nice view. What you're trying to do, of course, is something similar to what's in the book when you have your exploded view here, for instance, so that when you do the drawing, you have that available. This completes lesson 22.